All right, welcome again. One more grinding through algebra video, and this time we're going to solve for the equilibrium values of pi and y. Okay, so up here, I've written for us the AS and the AD curves. Okay, remember this is like inverse AD. I don't know the good way to call it, but it's AD written y as a function of pi, yeah? And we're asked to find equilibrium values of pi and y. So what we're looking for again, we have y here and we have pi here. Yeah, we have our AD curve, we have our AS curve. And we're looking for this point that gives us this value. This will be pi star, and this value will be y star. Okay, so just like before, we're just going to plug these two equations into each other and then solve. So I think what looks easy is to put this right here, because then we're like done. Yeah, then we just have to gather up the pi's and we're done. So let's do it. Of course, pause the video, have a try by yourself, and then hit play when you are ready to see my answer. Let's go. So I'm just going to straight up plug in y. So we have the expectation of pi plus. Now we're going to have fg delta over 1 minus b2 beta plus fg beta 2 alpha over 1 minus b2 beta pi minus fg b2 1 minus b2 beta expectation of pi. And then don't forget, after you're done plugging in, that we have one more term. So we're going to have plus epsilon pi. So now all that's left is to gather terms. So we need to bring the pi's together. So that's easy enough. We're going to have pi minus fg b2 alpha over 1 minus b2 beta is equal to, and then we also can gather expectation pi's. So we have an expectation of pi minus fg b2 over 1 minus b2 beta, expectation of pi. And then what's left, we have the constant term fg delta over 1 minus b2 beta, and we have the shock plus expected epsilon pi. So let's make sure I have everything. I have the constant term here, the constant term here. Pi went over that way. I have 1, 2 expectations, 1, 2, and I have u and u. Okay, perfect. So now we can do some factoring. So I want to factor this out, but I'm also going to want to make it into one big fraction, yeah? So what we're going to have is 1 minus fg b2 alpha over 1 minus b2 beta pi. But then I want to write 1 equals b2 1 minus b2 beta over 1 minus b2 beta, right? Okay, so then I can write this as making that substitution. I can write this as 1 minus b2 beta over 1 minus b2 beta. So this whole thing is just going to be equal to, there's a minus sign in the middle there. And so then I can actually do the subtraction in the numerator. So I can write this as 1 minus b2 beta minus fg b2 alpha over 1 minus b2 beta. So this whole thing I can write as one big fraction. It's going to be 1 minus b2 beta minus that thing divided by 1 minus b2 beta. Okay. And then on the other side, I'm going to do something similar. I'm going to factor out the expected pi. I'm going to have 1 minus b2 beta over 1 minus b2 beta, and I'll just make the subtractions. It's 1 minus b2 beta minus fg b2 divided by 1 minus b2 beta. Expectation of pi plus fg delta over 1 minus b2 beta plus epsilon pi. And then we can do the division. So maybe let's define gamma, another helper variable. Let's say gamma equals 1 minus b2 beta minus fg b2 alpha, yeah? So then we can, so this is gamma. This is gamma. So let's do the division. So the division will make our final expression, pi, equals 1 minus b2 beta minus fg b2 over gamma, expectation of pi, plus FG delta over gamma plus expected epsilon pi over gamma. Yeah, and the 1 minus B2 beta, that cancels, that cancels, that cancels. It doesn't cancel over here, though, so I forgot a term in the epsilon. So it should be 1 minus B2 beta over gamma epsilon pi. Okay, and that's our expression for pi. Let's draw a box around that, and we can check our answers in the PDF. Sorry, in the PowerPoint. For pi, we have FG delta over gamma. Good. We have 1 minus B2 beta plus B2 FG over gamma expectation. Yes, that's what we have. Then we have 1 minus B2 over gamma expectation of pi. Expectation epsilon pi. Okay, so very nice. So we have the right answer here. And then for the other one, you have options, yeah? Because now you could plug this into y, and you would just have your answer. That looks pretty messy. So another way, let's think about it for a second. How can we do this the best way? So the like brute force way is to just take our expression for pi star. Let's call this pi star, yeah? Because it's like the optimum pi. We could take this pi star and we could just write pi star here, right? And then that would give us our answer. The problem is just that it's messy. I guess, whatever, let's do it. If you see a better way to go about it, tell me in the comments. Delta over 1 minus B2 beta plus B2 alpha over 1 minus B2 beta. Okay, times everything. Times everything. That's really horrible. Okay, how else could we do this? We could start, okay, we could set this equal to the AS curve, maybe, and then solve for y. Maybe that's nicer. So if we just say that all of this, 1 minus B2 beta minus FG B2 over gamma, expectation of pi, plus FG delta over gamma, plus 1 minus B2 beta over gamma expected pi, epsilon pi is equal to expected pi plus FGY plus epsilon pi. Maybe this is nicer. And so then all we have to do is subtract, and divide. So what I want to know is what is gamma minus... So, okay, well, what we'll get is we'll get 1 minus B2 beta minus FG B2 over gamma epsilon pi minus epsilon pi plus FG delta over gamma plus 1 minus B2 beta over gamma expected pi minus I keep saying expected pi, epsilon pi equals FGY. So the question is, we just need to combine this and we have to combine this. Yeah. And then we'd be done after we divide by FG. So here we could write this as gamma over gamma. So we're going to have 1 minus B2 beta minus FG B2 minus gamma over gamma expectation of pi. Plus, let's do the epsilons next. So we'll have 1 minus B2 beta minus gamma over gamma, epsilon pi, plus FG delta over gamma equals FGY. And then we divide by FG. So in the very end, we're just going to have Y star equals, so FG cancels with FG, so we're going to have delta over gamma plus, here we're going to have 1 minus B2 beta minus FG B2 minus gamma over FG gamma. And then here, plus 1 minus B2 beta minus gamma over FG gamma. And that's our Y star. So I think that was a little bit nicer. Now, I'm pretty sure you can simplify this a bit more, right? If we go and peek at what gamma is, yeah, gamma is 1 minus, so gamma is equals 1 minus B2 beta minus alpha B2 FG, So if you have 1 minus b2 beta minus fgb2, so actually this 1 b2 beta cancels, this here and this here, and so we'll just have fgb2 minus alpha beta fg. And then the fg and the fg cancel with the top and the bottom, right? I didn't write things. This is expected pi, and this is epsilon pi. Okay, so let me make some space and actually do this out. So this simplifies quite nicely. You have gamma equals, so this down here, we have 1 minus b2 beta minus fg b2, and then minus 1 minus b2 beta minus alpha b2 fg divided by fg gamma. Okay, so now you see this one, here's plus 1, here's minus 1, here's minus b2 beta, here's plus b2 beta. Okay, so what this equals is minus fgb2 plus alpha beta 2 fg divided by fg gamma. And then you see there's an fg here, there's an fg here, there's an fg here. So this equals alpha b2 minus b2 over gamma, which is just b2 alpha minus 1 over gamma. Yeah. And lo and behold, this is exactly what we get for this coefficient. And so I put the minus sign up front here, and then you get 1 minus alpha instead of alpha minus 1, b2 over gamma, expectation of pi. And then for the epsilon pi, evidently there's also, some more simplifications you can do. So I leave those as an exercise to the motivated reader. It's like the lazy textbook way of saying I don't want to do it. So there you go. There's a bunch of math for ASAD. Maybe in the next couple days I'll put up some stuff about exchange rates. But you have all the tools now, right? You just have to use this sort of algebra system with different assumptions. So the different exchange rate analyses are going to be exactly like this, just with some additional terms thrown in and a little bit of logic. So in a few days I'll upload those, but this should be enough to keep you sated for now. Great. I'll see you then.